So this is the code for Lab 3. Here you can see the library and the files that I use. They're the normal two, and then you have the unsigned one to do the convert to integer function. Here you have defining the entity. Make sure you name this the same as up here. Then we have generic. We have 4 bits just so it's easy to change if you want to. And then our port, we have our clock, reset, up, down, and count. And then we end that and we go into the architecture. And then we have all our signals. We have our counter, which will assign the original count to counter at the end of each begin, pretty much. And then we have up, down, and reset to bounced. That is something we'll get to here. It's a switch to bouncer, which you'll see soon. And then Q1 and 2, which we'll also talk about. Here we can see the component, so I'm pretty much calling the switch to bouncer right here. And we can see button clock result because those are the 3 ports that we have here. So the switch to bouncer, as we went over in class, you have the counter that once you get to that final carry will act as an enable to let your either the high or low from the button go to the result. So that's all in this, and we call it here 3 times for the up, down, and reset. So instead of doing this all this logic down here, we're able to call it. So that's nice. And then here we have making each of the buttons clock pulse pretty much, because that's what we wanted for this one. So this is technically a clock process because you have to tie it to the original clock. So you can see here, this will all happen on the rising edge of our 50 megahertz clock. So I have the end of it hooked up to the middle, and the middle one is hooked up to all 3 of the pins technically. But I give reset here, I give that one the priority over the other 2. So if reset goes high, that one will be the most important one because you want it to reset. And so you have it, or if one of the 2 are different, then Q1 will go up. And that's because I don't want it going up if they're on the same one, because that would just, I think it was in the design requirement, you didn't want it the same. So yeah. And then here we have Q2, which is the end of that D flip-flop chain. So this one is dependent on the Q2 from before. So here I could not get it to be, it's technically synchronous with the clock, so that was as good as that was getting. So if reset is high, then the counter will go to 0. And then based on the rising edge of this Q2, if the up is high and the down is low, then it'll increment up. And if down is high and up is low, it'll increment down. And yeah, so here we see the simulation. Oh, wait. Oh. Here we see. I got rid of all of these, so now you won't be able to see them, but that was just for debugging purposes anyways. Here we can see when reset is high, everything is 0. In this space, everything is 0. Just how we meant it to be, really. And you can see when it goes down, it takes a little bit because it has to go through the debouncing, and then it has to go through the D flip-flops to make its own clock pulse. So it's not immediate that it'll go to 1. Well, in this case, it'll go down to 1, 1, 1, 1. But it does get there after a little bit. And there has to be a bit of a space in between, otherwise your debouncing signal will never go low, and that will mess up the clock. But in real life, you can't flip the switch fast enough for that to make any practical difference, so it's fine. And then here you can see another down, so it goes low. And then we have our ups, and you see it keeps going up until the reset, where nothing will happen. And you can see here, again, it doesn't immediately go back down, or I guess in this case up to 1. It takes a little bit of time, but it does get there. And then you put it to the board using this, and if I stop sharing, we'll be able to see it in action. So we use these 3. This one, the second one is up, the first one is reset, and this one is down. So you can see first bit being on the end and the last bit being here. Up, it goes up. And if I press down at the same time, it won't do anything. But if I press reset, all of it will be reset. So I'll just flip through the up really quick to see that all of them are working. And now if I go down one, it'll do the same thing until you get all the way down to 0. And you can see reset still works. So yeah, that's lab 3.